Hello all, welcome to the second session. In our second session, mainly we cover phasing operation and how to get mid pass and how to manipulate MCS. As I said earlier, if you are having existing part that you can directly open from this open part, when you open this one, then it will ask you a directory where you have saved that particular part. Now I am entering into this particular folder where I kept my models, and here if you keep all folders, then all files which are there in the folder will get highlighted. Specifically, if you are looking for a .prt file, then keep .prt. If you are looking for assembly file of a different extension, then you keep this assembly FEM files. If you are looking for a step file, then keep step file. According to the part extension, you keep the extension as it is. Otherwise, if you want, you can keep this all files so that you can clearly see .prt file. If it is step file also, you may see. So now I am opening this particular step file. When I click OK to that one, it will start converting that step file to .prt file by default. You may see here the imported step file, which consists of three model mainly. Three model means three basic models which are there in an assembly. So first I will hide these two components. To hide any component in an assembly, you need to untick this right mark. So if it is active, then it will highlight in a red color line, right mark. If you don't want to highlight that one, you can suppress by clicking single click. That to be left click. This is the fixture which we are going to consider in check, so that our tool should not machine this one. So it will avoid to touch this one. And second component is raw material which we are mounting on the top of a machine to get a finished good. So when I hide this particular one and when I open this particular casting part, this is our final product which we are looking for. Hence after machining we have to get this particular component. If you look at here, generally it is machined in three different setups, or it needs for this is the first setup where we can do machining of this pocket, and this pocket can be created, these step holes can be created. After that, this is our second setup, and this is our third. To make this collar structure, this is our fourth setup. So this component can be machined in four setups. So initially we will go with this particular machining of this particular pocket. So now we are there in NX modeling. I want to switch to manufacturing. Application, manufacturing. Now we are entering into the manufacturing. As you know, while entering into the NX CAM for the first time, it will ask you for the setup. CAM general you have to keep by default. In that you have to specifically take mill planer. As we are doing phasing operation for this particular component, so I need to choose mill planer. When I hit OK, the user interface starts converting into the manufacturing. You may observe here NX manufacturing and operation navigator get added. I am there in geometry view. If at all, if you are by default, if it is coming program order view, then you need to switch to geometrical view by right clicking here or click from this particular window. If it is not showing to you, then you may right click on this particular empty space, go for geometric view. The first and foremost case is to decide where we want to keep MCS. MCS is nothing but machine coordinate system, where your machine XYZ lies. Means our G code and encode will be measured from that particular point. Probably it is there in the bottom left bottom. If you want to take in upper direction or you want to manipulate this MCS to some other place, then double click on the MCS. When you double click on MCS, then double click means edit. In whichever in NX, if you double click on any command or a feature, then it means edit. Otherwise, some people will do right click, edit. Both the ways are same. So our main intention is to manipulate MCS. If I want to make a movement, then I can use this main if you are using for a single component. If you are using multiple components at a time in the same fixture, 10 components, 5 components like that, then that moment you have to keep this main as local and go on giving number of 1, 2, 3 like that. Even though in main also, if you want G55 as your output, that time you have to keep feature offset as 2. If you want G54, then make it 1. G56 3, G57 4, like that numbering you have to give. And so MCS I would like to keep at this particular top, then directly I can click here and I can select. So when you see here, one part only it has given, so that's why whenever I am taking cursor here, so it is not getting highlighted because of this particular thing within work part only. If you want to make, as this is an assembly, so I am changing it to entire assembly. Now I can select that particular edge to set my MCS at the top. So in this only, if you are having multiple multi-axis capability, if you want to make Z with respect to X here, then you can rotate it by clicking on these nodes. Instead of X, if you want Y, instead of Y, if you want to flip the axis, that moment you need to use this particular node. Suppose if I want to move this particular point towards left, I can use these cursors and I can specify the dimension up to which I want to have. So if I click to this arrow, then this particular MCS will move with respect to X, because you may see here it has highlighted in orange color. Basically it will see in yellow color, whatever you select, that will turn to orange color. That means you have selected that particular entity. If I give -50, then you may see that MCS is moved to left. So again I will take to that particular original position, then I have to give again 50 value. If I want to keep this particular MCS at the middle of this particular component, at that moment I can use this particular CSYS dialog box. If I click that 3 dots, there are multiple options which are available to you to manipulate MCS. To look at the different varieties, you click on this particular arrow, you will get different kinds. If you want to control with XY value, then go for XY. If you are going to select Z, X and origin, then give ZX origin. If I click XY, then it is asking me in which direction you want to keep X, in which direction you want to keep Y. That you can decide by clicking here. Sometimes if you want to specify the exact point, let's say the midpoint of this particular component, so you can see this is a like a rectangular block, and here I want a midpoint of this one and midpoint of this one. In between that, here there is a some point. So how to specify that particular component? By expanding here point dialog box, because I am intentionally working with the point, then I can go with this particular point. Between 2 points, I can select this particular between 2 points and save it. Now while giving point, you might have observed my units are coming in inches. if you want to see the component is in which unit, then you have to go to this file, properties, displayed part. It has taken inches because the uh, basic component which is assembly is in inches, so while doing step also it has taken inches. So when you directly open, this might happen. Instead of this, you have to import the step file so that it will come in that particular unit which you have kept. So I will show you that particular one. So I will say no close. Then I want that particular assembly in millimeter, as that is a step file. Now I am going to the particular new directory. Here I am keeping model, keeping millimeter, and I am giving that particular name, example 1. Say okay. Now we are there in a millimeter. Again, if you directly open, then it may come to inches or mm. If you want to be specific unit, then go to this new file, create a new file. When you enter into the modeling, then go for file, import, step. Either way, because that particular component which I opened is natively it is there in inches. Native means when you take that parametric model, that is there in inches, so that's why it has taken by default inches. Now what I did, I have converted into step file. While importing, I am keeping millimeter as my primary need. So here importing from the directory, the same directory I will go and I will say what all the model data you want. You click on, then say okay. Now before going further, we will see this time in which unit it is present. Go to file, properties, displayed part. Now this project is in inches, so sorry, millimeters. The same thing I am repeating again. I will turn off this particular stock. I want to keep my MCS at this particular one. Now you may see there are different number of datums which are highlighting. While creating those each and individual component coordinate system, that is showing. So if you don't want to see those, directly go to this view, show and hide, turn off these datums. So all the datums will be hidden. I want to switch to the manufacturing, application manufacturing, mill planar. Now I want to keep this MCS in between these two particular edges. The MCS name, expanding the point dialog box. Here I am keeping between 2 points. I'm selecting this particular edge and this particular edge. Now you may see there is a head point which is highlighting. It is okay to me. So your MCS is set at top. Sometimes if you have multi-axis capability, then you want to do this machining of this particular collar or a hole. That time you have to keep Z in this particular direction. Same thing, you have to double click here, select the center. After that I want to make it, instead of X I want to here as Z, so I am clicking here, giving a value. I can say 270 or something, or minus 90 also you can give, like this it will come. If you are having multi-axis capability, 4-axis capability. For this component you require minimum 4 axis to machine. Otherwise, if you are having 3-axis machine itself, then you have to go for 4 different setups. So like this if you do, then you can machine this particular region. Always keep in mind, whenever you are machining, At that moment your cutter will come in Z direction itself. So that's why you have to make sure that tool axis should be towards Z axis. So currently we are looking at the middle here. If you want to go back one step, then you have to go for undo. Undo shortcut key is Ctrl Z. So I have done undo. Redo means Ctrl Y. If you save this particular component, then you go for undo, it will not do. It will not be happen. So before saving you can do undo. So now it is okay to me, this MCS, and in MCS you might have observed there is a automatic plane as a clearance. If you are not given any clearance while generating operation, then by default it will come with a clearance of 10. So in main I am keeping this fixture offset as 1, so my output will be G54. Then say OK. After that you have to define workpiece. In workpiece, when you double click here, you will get this pop-up window. You need to specify a part which you require after machining, like this green color portion, dark green color part is our required component. So I am selecting that in a part. After that you may see it is asking blank. Blank is the raw material which you are mounting on a machine to get this particular part. So here we have suppressed that one. I will unsuppress this by clicking here in assembly navigator, select a blank, select this geometry. If you are having raw material model with you, then go for geometry. If you are not having model with you, I will suppress once again with this. Then go for different options. You have to keep offset from part whenever you are having forging part or a casting part. Why? Because in a forging they will keep some machining elements of 5 mm or 3 mm depending on the component size and the shape of the component. In casting also they will mention there is a 5 mm machining allowance is there. That time you have to consider this offset from part and you need to specify how much material is left there. Suppose if you consider 5 mm, we will keep 6 mm. So ultimately this model or the software will consider everywhere 6 mm material is there. So if you take bounding block is nothing but it will make a box with using extreme edges of X, Y, Z, and it will be look like this. This pinkish color is nothing but the raw material. If you have a raw material which is bigger in size compared to this, it is having a cut to cut model, sometimes you may not get the raw material with the exact size. Suppose in Z direction if I am having 200 instead of 190, I can make it 200. I can mention in this positive Z direction I am having 9.5 as my raw material. So like this you can mention. And if you are having raw material in X direction, Y direction, you need to give length and width. Then you go for in which direction that material is axis. If you keep this display blank on, then when you hit OK, so that will be there as it is. If you don't want to see that, because our intention is to consider raw material for in-process workpiece. If you don't want to see every time, then from here you need to turn off this display blank. Then see, now it will not be highlighted. The main intention of specifying blank is to specify the raw material. If you are having raw material model with you, if you are not having model with you, then it's not mandatory to have a raw material model with you. If it is a cylindrical or block or any casting part, if you are having, then well and good, go for geometry and select it. If you are not having, you may have different types of methods to select the raw material. Next is specify check. Specify check indicates the fixture you have to consider here so that your cutter will not go in that particular region. Here I will turn off this and I will go for specify check. Here I can consider by dragging this. So there are 13 components are there. So this is my fixture. I will select it. Once you see this one, this will show in red color. So this is our preview button or a display button. You can see the preview of raw material. This is a specific part. Preview you can see by clicking here display. Say OK. Now selection of my workpiece is done. Now it's a local. If you are having, as I said earlier, if you are having multiple set of components to be machined, then you have to take local level, otherwise you delete it, as we are having single component. I will turn on this particular required component by going to the assembly navigator and turning on this. Here I want to do facing first, because as we kept, there is a 9.5 mm material excess in the Z direction, that to be machined first by facing operation. To insert operation, you have to go to this create operation and select the type of operation you are doing. If you want to go do this facing, select this facing and set OK. That will get added here, plus sign. So this is a pop-up window where you may see there are nodes, different nodes. One is main, geometry, tool axis. So why they have given main? Because this is the minimum inputs you have to specify to generate any kind of operation. So then you have a geometry where you can specify a boundary. Already if you have specified anything, then that will be seen as a faint. Already we have specified part, blank and check body in a workpiece, that's why it is coming faint. So what are all the things which you have selected earlier before entering into the operation, that will be by default, it will consider that because it's a child of that particular workpiece. Tool axis, feed speed, that we will see one by one. So first you have to select cutter, for which cutter you are going to do facing. Go to this create new. If you want to create your own cutter, then you can use this bullnose cutter or end mill, chamfer mill, ball mill, spherical mill. Parameter, you can give this mill parameter, barrel, T cutter, according to your need. You have to select that one and you can specify that particular value. Suppose if you want to use the tools which are available in the tool library of NX software, then you may go to this retrieve tool from library, which kind of operation you are doing. When you expand this milling, there are also multiple types of cutters are available. If I am going with the end mill non-indexable, if you know library reference, then type on it, otherwise hit OK and it will show you all the cutters which are available in the directory. Now I am taking a cutter of end mill. Also look at the nose radius, corner radius, it is showing here. I will take this end mill 20 with the nose radius 2. Sometimes if you are not getting your required tool under the library, then you need to generate or create the tool. If you want to see the parameters of that particular tool, go to this edit display. You may see here end mill with the diameter 20, nose radius or lower radius as 2, tool length is 38, flute length is 22. Flute length is nothing but the side cutting edges length. In this image also you may see flute length. How many number of cutting edges are there? That is nothing but flutes from where your chips will go away. If you are using a ATC is nothing but automatic tool changer. That time you have to specify that particular value as T1, and adjust register is nothing but H value. Custom you need to keep it as same. Then say OK. Otherwise, if it is not available, then you have to create a tool. Creation of tool I will show you in the next operation or in the next session. Now our first and foremost thing, which is selection of tool, is done. After selecting tool, you need to specify a cut area, and go for this particular face. This I want to face it. Select. So before finalizing, just once you generate and see how it looks. So it is doing facing, and you may see it has taken cut pattern as zigzag. If you want to change a pattern, you can change it from cut pattern. If I want to follow periphery, then I can click follow periphery and generate it like this. If you want to follow part, when you see here in cut pattern, they have given the image also for reference. If you want to see the zigzag, then you may see here blue color lines zigzag. If you want zig means in single direction, if you want to machine, then you take Z. If you want only single pass, then you keep this profile. So mostly used for facing is zigzag, so you have to keep that one and generate. Currently it is having only one pass. Practically, if you see 9.5 mm material cannot be machined with a single pass. So if you want multiple passes, then you have to give multiple passes. Before going to that one, we have to mention the floor stock, how much stock you want to keep for finishing. Maximum people will not give any stock to this. Stock is nothing but the raw material which is left behind for finishing. You may see in this particular image, there is a pink color material is left behind, that you can keep if you want. If you want to keep both feed floor and part as a stock as same, then you turn on this one and you go for this part stock. Now when you turned on both bottom and side wall, if it is available, then if it is having same raw material with it. If you want to keep the raw material stock, and you can keep it. If you want to maintain the some clearance distance between the fixture and your pass, then you have to give check stock. Mainly now I won't give any floor stock here. Next is 3D IPW. This is very important. Nowadays we are using this 3D IPW. Earlier we are using a reference tool method. What is the difference in between those two is, if you take reference tool method in rest roughing, at that moment it will recognize the cutter wherever it is not went, there it will go. But in 3D IPW, it will recognize the material. Where is a material, there it will go. It's a material recognition. IPW stands for in process workpiece. So you can mention the minimum material to be removed. If I mention 1 mm here, then wherever 1 mm material is available on the part, there itself it will go and it will start machining. Sometimes if there is a material of 0.1, then it will not machine there, because we have given a minimum material removed to be 1. So that much material is available, then only it will go over there. So now I won't go in deep in this particular 3D IPW. Whenever we go for mill contour, that time I will show you how exactly this 3D IPW works. Now I don't want this within a single pass. If I want every time it has to machine 0.5 mm material, then I have to give this particular value depth per cut. Here I am mentioning depth per cut as 0.5. If I generate here, you may observe every time it is removing 0.5 material up to the face. Step over is nothing but after one pass, for next pass how much you are shifting. So while this is my first pass, after when it reaches here, so how much shift it has to do, that is nothing but step over. Currently it is taken 75%. Practically if you see, my maximum people will keep in the range of 60 to 75. So if you want to make it 60, you can keep it and you may observe the two passes are little bit nearer compared to earlier. So how you decide this step over is, it depends on the material of cutter, material of part, and the type of machine you are using. So for cast iron, steel or aluminum, you can keep 60 to 75%. For titanium or something, at that moment you have to keep in microns, otherwise your cutter will burn. So this plays a very important role in a tool life, deciding tool life. So these are the minimum things you have to specify to generate operation. Next is geometry. Geometry, already we have specified these three things. Sometimes if you get stuck somewhere, like if your machine table is having a 1000 mm limit in X direction, 800 limit in Y direction, Z direction I am not considering now. If you have limits, that moment if you are violating your limits by, if you are component of 1200, then you cannot machine on that particular machine because it's having a bed size of 1800. At that moment you have to split this particular operation into two by specifying a trim boundary, that we may see in another operation. So the trim boundary is nothing but you are specifying a boundary where you want to machine. Tool axis by default, for 3 axis it is Z. Keep Z axis as your default one. If you want coolant on off, you can do it. By default in a post processor it is defined coolant on and coolant off. It is, if it is not replicating in the output, that moment you have to turn on here. Next is feed and speed. In feed, spindle speed you have to mention. Here I am giving 6000 RPM and my feed is 1350. So after pressing both the values, you need to click this calculate, so that it will calculate feed per tooth and surface speed. Either you have to enter feed per tooth and surface speed, then it will calculate spindle speed and feed. Otherwise you give this spindle speed and feed, it will automatically take care. Someone might have observed on the insert box, insert means the cutter inserts, on box they will mention the maximum RPM which you can give for that particular insert and the maximum feed that you have given is okay or not for that particular cutter. You may cross check. Earlier olden days, you people are calculating this VC by pi d n by 60. Now you are getting values in internet also. If you click the type of cutter or type of material if you are using, then you will get a table. From that you can use. If you are having any senior with you who has worked on machine, you may ask them and keep these values 6000 or 1350 as per your machine or the part. So when you click this more option in rapid output, if you want rapid output as G0, then keep it G0. If you want, instead of G0, if you want to control that rapid motions also, that time you can give G1. So rapid feed you have to mention. Otherwise if you keep G0, then whatever the rapid feed which is given by a post developer, that will be taken by default. Means whenever there is a non-cutting move, like here red color, this is a non-cutting move that is in rapid motion. How one can see which color indicates what? So directly you can go to this options. In options you may see this edit display. When you click here, it will go inside that one. Part display colors, you highlight it, and you may see here red color indicates rapid motion, sky blue color indicates the cutting motions, and while approaching it's showing blue, while engaging it will show yellow, step over in green, cream color is in retract. You may change these colors according to your need, but these are the by default universal colors for Siemens NX software. So we are there in this feed and speed. So after that, if you see this mode, there is a feed you can mention. While approaching you can give, while engage means when your cutter and workpiece start engaging, that moment if what feed you want to keep you can mention. While doing first cut, how much you want to keep, you have to keep. So first and foremost, some people will keep this 80% to safeguard the cutter. When you suddenly hit with the 100% feed, that moment you may observe on the monitor of your machine there is a sudden increase in the load. So to avoid that one, they will keep 80%. So it is up to you which you want to keep it. If you want to slow down at a certain distance, then you may mention. So cutter will come to that particular region when it reaches this 110% or 100% of the tool diameter, then it will get slow. So you should not give this one, so it will affect your machining time. So next cut region is a blank outline it has taken. So that's why wherever the raw material is there exactly it is going and it is machining. And if you want only to be faced on that particular face which you have selected, at that moment you have to keep this as none. None when you keep in that particular region only, it will generate for that particular region. The simplify shapes, here we kept outline, so it is taking outline. If you take convex, it will take convex. For this type of rectangular, there is no such difference. If you are having irregular shape in sideways, that moment you may observe the different cut regions. If you keep a part outline, then exact part outline it will take. So better to keep blank outline itself. And the merge distance I kept 200, means if there is any distance between two different regions, then it will merge that one. Like this you have to do facing. So strategy, you have to give jet depth offset. If you want, you can give it. Otherwise, cut direction, if you want clean cut or conventional cut, it is nothing but a down mill up mill concept. So you have to click here and change. If you want down mill, up mill, and change it and specify. Sometimes you want a cutting direction, you don't want in this particular direction, if you want in another direction, then you have to give this cut angle, specify, and you can mention the angle with which you are willing to have that particular facing. Now you may observe cutter is coming and it is engaging 45 degrees. To verify that one, we have verify option here. In verify we are having two different methods. One is having replay, another is having 3D dynamic. If you do replay, then only cutter motion will be shown with respect to the pass. If you are willing to keep 3D dynamic, means along with the raw material, how exactly it is removing on the raw material, that will be shown. And also we may see here how much feed, what is the current location of that particular cutter, and the Z value, it will be shown. Some people may read this particular one, go to. It is better to validate before going to the machining. When you click 3D dynamic, you may see here with the raw material I am decreasing the animation speed. Now you may observe how exactly it is removing. Now as we have given 45 degrees zigzag, that's why it is moving in 45 degrees zigzag motion. If you want to increase the animation speed, you may increase it. It's going for the next second depth. As we have given 0.5 every time, it is removing 0.5 material. I am increasing my animation speed. I want to show you how you can recognize how much material is left behind. Sometimes there are some regions where your cutter is not entering and you cannot predict without doing any validation. You cannot predict that there is a material. If you do this toolpath visualization, then you may come to know by looking at the color also, yeah, there is some material. Then you can use a smaller cutter to machine that particular region. So my intention is to speed up this animation to get. Now my validation is over. I can see here facing is done. Even though if I want to cross check that on top of face there should not be material, then I have to use this analyze option. When I click analyze, then it will show me by colors also. If it is showing this dark yellow color, then it is super finish or 0, there is no material. So maximum material will be 106. If you want to see this particular point, you click on that and it will show you how much material is left behind. So as we are doing facing for this particular region, here I want to see, yeah, it has done exactly facing which is required. Like this you have to cross check. In this particular toolpath validation, there are different types of methods, or IPW you can save it as a component that we may see in some other operation. So now we have done facing by using the floor facing option. So thank you.